Hi everybody, welcome to another video in Math 1332, section 3.6, negation of conditional statement and De Morgan's law. So, we define the negation of the implication or the conditional statement. A P implies Q, or if P then Q is P and not Q. So this expression can be expressed as this. So what we're going to do now is we're going to prove this. So we just need to show that the two tables, those two columns, are identical. Say only P and Q, so we only need 4 rows. Maybe that's enough. Right, so we have the statement P or Q, P and Q. So true, false, and then true, false. We do this a few times. Now, there's a lot. Let's just focus on that left hand side. So first we're going to do P implies Q. So the conditional statement, if P then Q, is going to be false only if true implies false. So we have false here, and everywhere else is true. And now what we do is we're going to negate that. So the true become false and the false become true. So true turn to false, true, false, and false. So we do have the first column. So at one side. Next we will have P and not Q. So we need not Q. So this is P, and we need the column that is not Q. Right, not Q. So we turn all the true false values to the opposite, true to false, false to true, false, and true. Now we just do P and not Q. So P and not Q. So that is P and this is Q. So this is an AND operation. So it is true only both of them are true. Yeah, both of them are true, and will be false everywhere else. So true, false, be false, 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 true. Now this is the second column that we need for the right hand side. That for the left hand side, as you see, they are identical. So that proves that they are equivalent, logically equivalent. Right. Now let's write the negation for the following. If it rains, then we do not go to the beach. So we just write if P then Q. They want the negation to this. Let's start with so this is P, and we go to the beach, Q. So that is the implication there. Now we do the negation of this. The negation is P and not Q. So if we turn that into a negation, it's going to be P and not Q. So we just write P, it runs. Notice that it's no longer the implication. So it's not, we're not going to write if, because the if work for the arrow. This is N, we don't need that. So it runs, which is P. That means N. So we have to turn this, we do not go to the beach, to the opposite value, so that we say, and we go to the beach. Right? So again, it's just an AND statement. So and just negate the second statement. Right, next. If we work overtime, then we'll get paid more. Alright, so this is P. That implies we'll get paid more, which is Q. So we start with P and then not Q. Negation of this is P and not Q. So if we work overtime, stay the same, except for the if, because this is not a conditional statement anymore. So we work overtime. And we have to negate this, and we will not get paid. More. Yeah. So just like that, straightforward. Right. Now, the second one, De Morgan's law, it says that the negation of a conjunction is the disjunction of the complements. I'm sure it's not the complement, it's the negation. Let's go that again. Negation of the conjunction is a disjunction of the negations, and negation of a disjunction is a conjunction of the negation. Right. So we just make a table and prove this the De Morgan's law. Right, so the second statement, true, false, true, false, true, true, false, false. So that all the scenarios there. Now focus on this one. So that. So first we do the conjunction P and Q. It is true when both of them are true and false everywhere else. Now we just need to negate that. So false, true, true, and true. So this is the first column for the left hand side. Now for the right hand side, we're going to do negation both of them, and we're going to do the disjunction. So now we'll do not P and not Q. not P, so that is P. We're going to negate false, true, and not Q, which is this one, true, true. And we do the disjunction. Notice that all the operations say that we do the negation first and then the disjunction and conjunction after that. So, and this is disjunction. It is only false if both of them are false. Everywhere else is true. As we see, these two columns are identical in true values, so they are equivalent. Logically equivalent. Right, I'll do the same thing for the next part of the De Morgan's law. P, Q. So true, false, true, false, true, false. Right. So I'm going to do inside the parentheses first. I'll focus on the left hand side here. So we're going to do the disjunction first, and this is false only when both of them are false. Everywhere else is true. Now we do the negation of that. True become false, and false become true. Right, so we have one column. Right, next we have negation of P, negation of Q first. And after that, we just need the conjunction. Right, not P, so that P turn to opposite values, true to false. And now this one will turn opposite to that. Now the conjunction. And this is only true when both of them are true, everywhere else false. It's true when both of them are true, everywhere else are false. And as you see, those two columns are identical, so they are logically equivalent. Right, finally we just have more exercise of this. Write negation for the De Morgan's law. Right, so we look at this. Some college professors are entertaining lecturers or on board. So this is P or Q. Right, and this is R. So the De Morgan's law say first we will change the negation. Change the connective from or to N. He said I'm bored, meaning I'm not bored. So we turn that into not P. Let's just write out this one first. We have P or Q, the negation of that. De Morgan's law say not P and not Q. So we have not Q already. Now just write not P. We cannot just draw not here, right? Remember, for the negation with the connective, we have to change from quantifiers to universal. So we have to change that to all. All correct, professor. And not. So we change negation and also change the quantifiers from existential to universal. Are not entertaining lecturers. Sorry. Space. Right. So again, not P, not Q, and the connective change from disjunction to conjunction. So, and with that we change from universal to existential. I'm sorry, the other way around. Existential to universal, and then throw the not. Is that we say on-call professor are not entertaining lecturers, and I'm not bored. Right. Next, all students do laundry on the weekend, and I do not. So the N here turn into all. I do not. So change that to negation. So I do. Now we just need the negation of this. So all students do laundry on the weekend. That has the universal quantifiers. So we change to existential. All turn to some student do laundry, so they just don't do laundry. On weekend. Some students don't do laundry on weekends, or I do. Right? So I said negate both of them and then change the connectives. Right, next, the jacket is both warm and light. Even though it's just one sentence, but this can be rewritten as my jacket is warm and my jacket is light. So we turn N to all and negate both of them. We say my jacket is not light. Just this negate. My jacket is not warm. Right, so that is the De Morgan's law. Right, so, and with that, we've just write actually the here to give P around the P and Q originally. That's why we have negation of it is not P or not Q. Right. So that's all I want to cover in this section. As always, thank you for watching and see you in another video in Math 1332.